Hi there, I'm Dr. Carl Unsworth from STFC Daresbury Laboratory, and I'm a software engineer in the nuclear physics group there, supporting the UK nuclear physics programme by developing data acquisition software. I'm going to tell you a little bit about how I got here and what my role involves. So I went to school in Liverpool at the Liverpool Bluecoat School before attending the University of Liverpool to do a BSc in physics, and that was started in 1999. I then did a few years of work and travel post-graduation before deciding that I wanted to pursue a career in science research and coming back to study an MSc in radiometrics in 2007. So radiometrics is measurement of radiation, and then from that I went on to do a PhD in nuclear physics between 2008 and 2011. Following the completion of my PhD, I moved to Vancouver in Canada, where I worked at TRIUMF, which is Canada's facility for nuclear and particle physics research. While I was there, I worked on the maintenance, operation, and upgrades of the Tigris gamma ray spectrometer. Tigris stands for the TRIUMF Isaac Gamma Ray Escape Suppressed Spectrometer, and there's a picture of it here. And we used the accelerator at TRIUMF to produce exotic nuclei, and then we used Tigris to analyse the radiation that was produced as these exotic nuclei decayed. And using that, we were able to investigate the nature of the atomic nucleus. We were able to investigate the origin of the chemical elements in astrophysical nuclear processes, and we were able to use it as a testing ground for the basic standard model of particle physics. So following my time at TRIUMF, I then moved back to the University of Liverpool, this time as a postdoctoral researcher, and I worked on the development of radiation detectors. But this time, rather than fundamental nuclear physics, I was working more on applied nuclear physics. So systems I worked on had applications in radioisotope dating, in security, so checking for radioactive material being moved around where it shouldn't be, medical imaging, and nuclear imaging for decommissioning applications. So that's nuclear facilities like power plants, when they're shut down, they need to be done safely. A lot of attention needs to be paid to the radiation levels, and we have helped build in devices for use in those applications. Okay, in 2018 then I moved into my present position, which is at Daresbury Lab, just outside Warrington. I now work as a software engineer in the nuclear physics group, and as I said at the beginning, supporting the nuclear physics group by the nuclear physics community rather in the UK by developing data acquisition software. So what is data acquisition? What is data acquisition software? If we look first at the very first nuclear physics experiment, so you may have heard of this. This is the first nuclear physics experiment was known as Rutherford scattering, and Rutherford, who is the guy on the left hand side there, designed an experiment to study the structure of matter by scattering alpha particles off a thin piece of gold foil. And by looking at the angles through which the alpha particles were deflected, Rutherford was convinced he'd be able to learn about the internal structure of the atom. Okay, but Rutherford was a distinguished scientist already by that time, and he was a busy man. So he actually had his students, Hans Geiger and Ernest Marsden, who were the guys on the right hand side there, to actually perform the experiment for them. and they would sit in a darkened room looking at the instruments that you can see pictured there. Well, that's actually a replica, I believe, but an instrument very much like that. And they would look through the scope that you can see there and count flashes of light produced in a scintillating crystal as the alpha particles hit it. And then they could move the scope and the crystal to different angles, and then they could see how many alpha particles were scattered by the gold foil into each particular angle. You've almost certainly heard of this experiment before. So the data for that experiment was collected by Geiger and Marsden. So in a way, Hans Geiger and Ernest Marsden were the first nuclear physics data acquisition system. Okay, so nuclear physics has come a long way since then. So modern experiments, like the one pictured there, which is called AGATA, the Advanced Gamma Tracking Array, they create newer data acquisition challenges. So let's think about some of the figures there. So radiation can hit at detectors in a typical experiment tens of thousands of times per second. There are many detectors involved in a single experiment, so that's a lot of radiation to count. We also look at other bits of information, such as how bright the flashes are, not just how many flashes there are in a certain amount of time. And the data that are produced from these experiments are produced at gigabytes per second. That varies a lot, but that's a typical number. So gigabytes a second, that's a lot. That's something like the entire works of Shakespeare every 0.03 seconds, or the entire English Wikipedia text in a compressed format every 14 seconds. And that's just not practical for humans to keep track. No matter how many PhD students you throw at the problem, you can't have them all sitting in a darkened room and collecting that amount of data. Okay. So physicists build electronic instruments to do the readout for them. So we have our detectors coupled to electronics devices which capture all the information that's being generated there. And these electronic devices need software to control them. And that's what I do. I build, design, operate software for collecting data in nuclear physics experiments. So I guess the other thing to tell you about is how might this work in scientific software differ from day-to-day work if you were in commercial software engineering, say. Well, there's much more variety in the day-to-day work. You know, if you're in commercial software, you might be a user interface specialist who designs the interface for what people interact with. You might be a low-level person who writes the code that talks directly to electronic devices. Or you might be somewhere in between doing data analysis or things like this. But we have to cover that whole spectrum, so it's interesting, and you don't get a chance to become as expert in any one thing as you might do in the private sector. But you get a lot of experience. You also have the opportunity to work with a diverse range of specialists, so not just physicists, but electronic engineers, mechanical engineers, project managers. There's an awful lot of people involved in these projects, and you can learn a lot from all of them. Okay, and if you're interested in that kind of role, what should you do? You should definitely keep up with your physics and your science learning. You also learn a programming language. Python is a popular choice. And maybe learn another one when you're done with that. C is important if you want to write code that interacts with hardware. And you don't necessarily need to limit yourself to physics, because other sciences also need programmers, and increasingly so as time goes forward. So thanks very much for listening, and I hope this was informative for you. Cheers.